Have you ever gazed at the night sky and wondered why, with billions of stars and potentially habitable planets, we haven't encountered any signs of extraterrestrial life? This question opens up the discussion of the Fermi paradox, a conundrum named after the physicist Enrico Fermi. The paradox is simple yet profound, asking why we haven't detected signs of other civilizations despite the vastness of the universe. The enormity of the cosmos is hard to fathom. Picture this. There are around 100 billion Earth-like planets out there. If just 1% of these planets developed intelligent life, the number of civilizations in the observable universe would still be in the billions. Yes, you heard it right, billions of civilizations. Yet our radios remain silent. The night sky, filled with a myriad of stars, doesn't seem to harbor the chatter of alien civilizations. This silence is what puzzles scientists and fuels the Fermi paradox. If there's such a high probability of life-sustaining planets, where are all the extraterrestrials? There are organizations like SETI, the Search for Extraterrestrial Intelligence, that dedicate their efforts to find signs of intelligent life beyond Earth. They scan the cosmos, searching for signals that might indicate the existence of these elusive civilizations. But so far, their search has been in vain. The Fermi paradox doesn't just challenge our understanding of life beyond Earth. It also challenges our understanding of our place in the universe. It raises questions about the nature of life itself, the probability of its existence, and the future of our own civilization. Could it be that the distances between stars are simply too vast? Or maybe intelligent life is not as common as we think? Perhaps there are civilizations out there, but they lack the resources to detect and communicate with us. So the question that has puzzled scientists for decades remains: where is everybody? Imagine a planet, Planet X, advanced by 3.4 billion years, a Type 1 civilization, harnessing all the energy of its planet, a place where the inhabitants have harnessed the power of the atom, the sun, and everything in between. This is a world where science is not just a discipline, but the very fabric of life itself. Now, to comprehend the scale of this civilization, think of our own planet Earth. We are still a Type 0 civilization, yet to fully harness the energy of our own planet. But Planet X, they are light years ahead, both figuratively and literally. Their energy consumption and capabilities are such that they have the potential to manipulate their entire planet's resources at will. One extraordinary outcome of such an advanced civilization is the mastery of interstellar travel. Planet X, with its abundance of energy and technology, would have likely conquered this frontier. The inhabitants of this planet could be traversing the cosmos, colonizing galaxies, and perhaps even manipulating the very fabric of space and time. With the universe as their playground, imagine the possibilities. The concept of Planet X gives us a glimpse into what could be out there, beyond our blue planet. It reminds us of the vastness of the universe and the potential for countless other advanced civilizations that could exist. In fact, if we apply our current understanding of science and technology, we could speculate that there should be at least 1,000 Type 3 civilizations in our galaxy alone. These civilizations would have reached a level of advancement where they could harness the energy of entire galaxies. The implications of this are staggering. If such civilizations exist, their presence would likely be noticeable, perhaps even undeniable. Yet, we have not seen any signs, heard any signals, or been visited by extraterrestrial beings. This raises the question, why not? But here we stand on our blue dot, yet to be visited by extraterrestrials or reach other star systems. Enter the Great Filter Hypothesis, proposed by Robin Hanson, suggesting an insurmountable barrier in the path of advanced civilizations. This is the idea that to evolve into an interstellar species, a civilization must successfully navigate through a series of crucial developmental stages. Each of these stages represents a potential filter, a hurdle that must be cleared for the civilization to continue its journey towards the stars. First up, we have the formation of life. This is no easy feat. The conditions need to be just right. A planet must be in the habitable zone of its star, where it's not too hot, not too cold, but just right for liquid water to exist. This is often called the Goldilocks zone. But being in the right place isn't enough. The planet needs the right ingredients for life, like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And even then, the spark of life isn't guaranteed. Then, assuming life does form, it needs to survive and evolve. It must develop tools and technology, a process that took billions of years on Earth. And this is where things get tricky. The development of technology is a double-edged sword. On one hand, it's necessary for a civilization to reach the stars. On the other hand, it could lead to its downfall. Nuclear weapons, artificial intelligence, climate change. These are just a few examples of potentially civilization-ending technologies that we've developed in our relatively short existence. Finally, a civilization needs to colonize other worlds. This is no small task, requiring advances in technology and science that we can only dream of today. And even if a civilization manages to colonize other worlds, it must avoid self-destruction and outside threats, like asteroid impacts or gamma-ray bursts. So, the road to becoming a spacefaring civilization is fraught with hurdles. Each of these hurdles represents a potential great filter, a point at which a civilization could fail and cease to exist. Could it be that we, as a species, are standing before, or perhaps have already crossed, this great filter? So what could this great filter be? What could possibly stand in the way of a civilization's galactic colonization? Let's delve into some of the theories. One idea is abiogenesis, the creation of life from non-living matter. This process, as miraculous as it seems, is perhaps so rare and complex that it becomes a significant bottleneck in the emergence of life. Maybe we are among the lucky few, the cosmic lottery winners, who managed to leap over this hurdle. Another possibility is that advanced technology could lead to self-destruction. As civilizations become more advanced, they may create technologies that have the potential to wipe them out entirely. Nuclear weapons, artificial intelligence, or even genetically engineered viruses could all pose existential risks. The road to becoming a spacefaring civilization is fraught with dangers, and perhaps many civilizations self-destruct before they can reach the stars. Then there's the idea of outside events causing annihilation. Catastrophic events such as gamma-ray bursts, supernovae, or asteroid impacts could wipe out life on a planet before it has a chance to spread beyond its home solar system. The universe can be a harsh and unforgiving place, and survival is far from guaranteed. But what if we've already passed the great filter? What if the challenging phase lies behind us and not ahead? Maybe the emergence of complex multicellular life, the leap from simple organisms to creatures like us, is the rarest event in the cosmos. If that's the case, we might be among the first, if not the only, civilizations to have made it this far. These are daunting possibilities indeed, but there's another theory that suggests a more peaceful explanation. Welcome to the cosmic zoo, where Earth is an exhibit and extraterrestrials are the spectators. This intriguing idea is known as the zoo hypothesis. According to this concept, advanced extraterrestrial civilizations consciously avoid contact with Earth. They do this to allow us to evolve and develop naturally, much like the animals in a zoo. Imagine, if you will, an advanced civilization, capable of traversing the vastness of space, observing us from afar. They watch as we make strides in technology, as we grapple with our inborn curiosity about the cosmos, and as we inch closer to becoming a spacefaring civilization. But they do not interfere. They do not make their presence known. They let nature take its course, letting us, the inhabitants of Earth, grow and evolve at our own pace. Of course, this hypothesis is not without its limitations. It assumes a universal motive among all extraterrestrial civilizations, a shared ethos that values the natural evolution and development of other life forms. But what if alien cultures are as diverse as the cultures here on Earth? What if some extraterrestrial civilizations are eager to establish contact, while others prefer to observe from a distance? And yet others have no interest in us whatsoever. And then, there's the question of time. The universe is about 13.8 billion years old. In the grand scheme of things, humanity is a relatively recent addition. The chances of an advanced civilization discovering us in the narrow window of our existence are, admittedly, slim. So what does this mean for us, the inhabitants of this cosmic zoo? Are we destined to forever be the observed, never the observer? Or are we on the cusp of joining a greater interstellar community with our own stories to tell and wisdom to share? So, are we alone in the universe, or just in a cosmic quarantine waiting for the right time to join the interstellar community? The answer remains a mystery, a testament to the boundless enigma that is our universe. The Fermi paradox, the great filter, and the zoo hypothesis, each one adds a layer of complexity to our understanding of the universe and our place within it. We've delved into the depths of the Fermi paradox and pondered the silence we face despite the potential for billions of civilizations in our observable universe. We've explored the idea of the great filter, that daunting barrier that might be the reason we haven't yet encountered extraterrestrial life. We've considered the zoo hypothesis and the possibility that we are being observed by advanced civilizations left alone to evolve naturally. The search for extraterrestrial intelligence continues as humanity's curiosity remains unquenched. Our quest for knowledge, for understanding our place in this vast universe, propels us forward. In this cosmic journey, we may be but a speck of dust, yet our curiosity and our quest for understanding make us truly unique. Until next time, keep wondering, keep questioning, and keep looking up at the stars.